Our first speaker is Russ Miller. He runs a podcast, so I wrote down all the stuff I'm supposed to say, and now I didn't remember to bring it out. So Russ has led a team creating cloud-based applications and service monitoring. He's interested in lean techniques, which is evident in the title. He runs a podcast, and he's going to summarize the lessons learned. So turn it over to Russ.
Can you hear me okay in the back? Great. All right. Well, good morning, everyone. Thank you for coming. It's nice to see such strong interest in a topic that's near and dear to my heart, continuous delivery, and again, within this context of lean principles. And so, as Len was saying, I was working for a company called SunView Software, and I was the CTO and co-founder, but I just left on Monday. So I'm in the middle of a big transition to another new small company. And so I'm leaving a lot of this behind, but I'm very proud of the team I was working with and what we accomplished, and I learned a lot in the process. It was great. And so I'm here to talk about some of what we learned. And I could talk for an hour or two, but I have practice, and I guarantee you it'll be short enough that we should have some time for questions here. And by the way, the podcast is just a hobby, a labor of love. And if you want to, we're always looking for guests, and probably many of you have run into Bet Correa. She's hard to miss, but she's the co-host on that. I should have asked. Oh, here's the clicker. Let me see if I can make this work. It is. All right, we're good. All right, so the context of the lessons they were learned within a greenfield project, started from scratch, and it was within this company our first attempt at doing something natively in the cloud. We have taken a legacy product and forklifted it into AWS, but in this case we started from scratch developing this system. It's out there in beta form and available. You can go to livepulse.co and see it. It's a non-trivial cloud-based monitoring tool for monitoring systems, and it's kind of got some ideas that came out of DevOps for monitoring and doing it in a social and collaborative way. But I'm not going to go into any details beyond that on what this does. And it was also for us a kind of a pilot. We've done some amount of Agile, but for this particular project we tried to go in much deeper and be truly Agile and apply more lean principles. I don't know how many of you are familiar with this book. How many people have, helped me understand how many people have gone deep into this topic? So we got a good percent, maybe 25%. So just to kind of get started and be on the same footing here in terms of the definition of what I'm talking about when I talk about continuous delivery. It's an automated approach to software delivery characterized by frequent and predictable delivery of incremental units of business value. So small batches of value for the business. Obviously, in the end, that's what we're paid to do, is get that value to the customers, put it in their hands, and help the business make more money. And to do so, you need to be leveraging continuous integration, automated testing, both unit testing and acceptance testing, and then automated deployment. How many people here are part of a team that is doing continuous integration? Can you raise your hand? So probably more than I would have expected, perhaps. That's great. How many people are doing automated unit testing? Great, most of you. Automated acceptance testing? Fewer hands there, definitely. All right. And how about automated deployment? Keep your hand up if you're doing automated deployment into the cloud. Okay, so only a few hands left there, maybe 3 or 4. All right, well, that definitely helps me understand as I go through here where to go deeper. So how many of you have seen this, the Amazon drones? They were on 60 Minutes, kind of popularized. I would hope most of you. But so the idea is, in Amazon, they're very focused on being lean. Great application of lean principles that goes beyond software. They're trying to deliver to you that which you want as quickly as possible. So you go on the website, you order something today, they want it in your hands today because that reduces waste in a lean sense, right? Because You want it, they give it to you. You don't have time to rethink about, oh, maybe I really didn't want it, and you change your order. Or maybe you find that same item on a competitor's website and you cancel your order. It eliminates waste. Meanwhile, the faster they get it to you, the faster they get the feedback, right? Lean is all about feedback. So the quicker they get it to you, the faster maybe you go out on their website and you update it with your feedback as to whether you like that product or not. And the same thing is true with continuous delivery. This, to me, is a great metaphor for continuous delivery. That train, the freight train, delivering a large set of features, every 6 months, every year, is a metaphor for how we've typically done it, and even to some extent how on the legacy product that the same company I was working with on this is still doing their legacy delivery. How many Formula One race car fans? I'm sure there's some, yeah. So, so to me, again, continuous delivery, much more like a Formula One race, and certainly for mobile applications, for software as a service out in the cloud, Netflix, a great example. It's turned into kind of a Darwinian race, a battle for the customers. You have to be continuously integrating. Obviously, it has to be continuously available. The engineering team needs to be, on a daily basis, keeping that software working and incrementally adjusting it with the same kind of mindset a pit crew would be working on a race car as it come in. Doing a small batch set of improvements to it, tuning it, making it incrementally better, but it's always running, always able to drive it around the racetrack. Not like a backyard mechanic that you might find in the Midwest where I grew up. Okay, so I have this slide in here to remind me to talk about the fact that these architecture techniques that I'm going to be talking about don't just help with continuous delivery. There's more payoff, and that's important, especially as you consider taking the risk of adopting them. And so it helps you be more scientific, do the hypothesis testing, do the innovation, stay away from the ivory tower approach to software development that we've all kind of been forced to do in the past, because if you're not out in the cloud, it wasn't always so easy to interact with your customers and instrument it and get the kind of feedback that could help drive those tests. So, A/B testing was mentioned by Diana in her talk earlier. And, so some of these techniques can help you go deeper in the architecture in terms of doing some of those A/B, not just on give them this web page or give them that one, but maybe go deeper and do this algorithm versus that algorithm. So it's not the main focus, but I just want to point out that there's other payoff for adopting some of this. So I showed you the Amazon drones, and that's how Amazon wants to deliver their software. But for us here, we don't have the drones, but even as we're sitting here right now in this room, there's 3G and 4G packets hitting some of your smartphones and updating apps. I'm almost guaranteed somebody's at least being notified about an update, if not actually having it automatically applied. And again, that's the world we live in. And some of those probably could even be a matter of continuous deployment. And flowing through a pipeline, the code's being checked in, going through these automatic stages, possibly with the push button deployment or automatically deployed, depending again on the criticality of the application and the environment. So I like to think of it as an assembly line in terms of a car manufacturing plant in the flow. The request for the feature flows in one side, the feature flows out the other, and it shouldn't be kind of in lockstep. It should be a smooth, continuous flow of these things through this pipeline. I had an opportunity working with John Deere to go to the John Deere harvester plant, which was, they showed the tractors yesterday, but I was at the combine plant recently, seeing how they're taking the raw parts in one part, and the combines are being driven out in the other. It's really amazing. And they're applying lean principles there, and the same thing for us. It just takes on a different form. So this was our goal, was to build one of these pipelines. We did it. We didn't know if we could deliver software every day, every hour, but we at least started with the goal of doing it every week. So, again, just to kind of put a picture around our goal, this is it. The continuous delivery of these features, much like those drones, landing in parallel on the devices and making the business value immediately available. However, we were a little stymied in this goal by something we didn't expect. So in terms of trying to get these features that were flowing through this pipeline all the way out into production, what happened is that we started to see a backlog going that last mile from test to production. At first, it wasn't clear, and again, it came from a surprising place. And it was so if you think about the Amazon example again, you couldn't let new drones take off until the other ones land. So you end up with this bottleneck, this backlog that you have to deal with. Because, again, keeping with the other metaphor, the cars, we're all probably familiar with the andon cords that Lean talks about stopping things if they go wrong, just like in a Toyota plant. You can see the cords hanging down there, the white strings. So when something goes wrong on the plant floor, they stop that. They go do root cause analysis. So we were having to pull that cord in a virtual sense way too often, and that's backing up even starting work. So in a lean sense, you don't want to start something new until you get that batch that you started all the way through your process, all the way to done. So this is a line I use a lot with the developers that work for me. It's not just done. Is it done, 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 done? Because developers, as a lot, no offense to anybody, because I'm also guilty, have ADD at a higher rate, I think, than the average population. And so keeping them focused on starting and finishing all the way through, that's really where I love Lean, because it gives you a much better framework for talking about what done means. The business doesn't care if it's done in a sense of testing or, okay, the code's checked in. They only consider it done when that actually goes into production. So we did use a Kanban board. I know Joe Justice talked about it yesterday as well. So in terms of visualizing the flow, Kanban boards are great. And we were using that and seeing it piling up. We couldn't get it from test to done. That was the challenge, and we didn't understand why. So, again, Lean, there's a lot of focus about small batches. That it's huge, right? You want to, I don't know if anybody knows what Little's law is here. Queuing theory and its relationship. So I don't have time to delve into it, but I would encourage you to go look that up and look the theory behind this and why small batches matter in terms of getting smooth flow and a fast pace of flow. And this is obviously a joke. I know we're not allowed to advertise products here, but at the same time, it turns out that within software development, because of the nature of that which we work with, you can't see the actual batch size. So Joe Justice, working on his cars, can see the batch size. It's something tangible, physical. You have to lift it up and move it. And he has his cards on a Kanban board, but there's no physical object for us like there is for that. And so it turns out, in this really interesting article in Harvard Business Review that talks about it, the 6 myths of product development, and how we in software don't get to see the batch size. We don't realize how big it really is. And that was the case for us. We thought we were doing small batches. We had these cards on the Kanban board that represent each unit of work, that each incremental improvement to the business value that we were intending to deliver. But in the end, we actually had a much bigger batch size than we knew. And in terms of learning about it and understanding it more deeply, this book by Donald Reinerson, we came across it at one point within the team and started reading it. And it turns out there's something called the fluidity principle that I wasn't aware of. So just to read it here, loose coupling between product subsystems enables small batches. So, we're architects. We're not the new guys on the block. I've been to SATURN enough times to know that coupling is a bad thing. But it turns out that coupling is even more of a problem in terms of deploying these units of work within this sort of the build pipeline. And there's a quote within this book that I love also, and I have to give some credit to John Esser and Russell Barnett from Ancestry.com, because that's where I first heard them, and I clued back in on this quote. Once a product developer realizes that small batches are desirable, they start adopting product architectures that permit work to flow in small decoupled batches. So it was at this point that it started to dawn on us what was going on and why we were seeing this. We're having trouble going that last mile. So here's, at a real high level, the architecture of this system that I was helping the team to build. And in particular, just to draw on an example, this search service, it was originally just an object interface, and it wasn't a decoupled service. We had quite a few other services, but that one hadn't been broken out. So in order to redeploy that, we had to deploy all of those parts that it was part of. So there was this dependency, this coupling, and this wasn't the only example, but this is one that's convenient to talk about. So we go to where Diana was talking about in her talk, microservices. So the solution for us was to take some of those components and make it more granular, and not just use the solid principle and some component technology to make it decoupled, but to go farther and leverage the cloud. Again, we were working on cloud-native system here. So in that sense, it actually is a separate deployable on as many VMs as we want, the service running out there. And the cool thing with the cloud is it's all automatically deployable. Nothing's manual about it. It can, we just push a button and new instances of this are pushed out there. And there's lots of other advantages that I don't have time to go into, but I encourage you to look at. So again, other reasons to go to this approach. And so, problem solved, right? We get these services and we just push them out there independently. Well, you guys know that reality's never that simple. So what happens when you have a feature that cuts across your stack more deeply, and maybe you have a different team working on one of these components? You need a different way to solve that problem. Just being able to deploy one service isn't going to help you. So what we found, at least to think about it, is virtualizing the pipeline. And the way that we did that was using feature switches. So feature switches, and if you go look up Twitter Decider Framework as an example, this is an approach for being able to put those features out in production but have them disabled and flow out maybe incrementally, piecemeal, each of these the components in that hierarchy. So I encourage you to go check that out. And it pays off more than in terms of helping with small batches. Again, it could help with that A/B testing because you could turn that feature on just for some users. And again, even for like the canary model, turning it on just for the QA group perhaps even, or just for some cohort. So in terms of managing risk, it helps. Another technique, I'm not going to go into depth on here. There's a lot of information, and I have some resources in the slides. Branching by abstraction. So the ability, again, where you have dependencies and you need to break them. So in terms of lean, how do they feel about branches in the source code control system? It's waste, right? So if you're not going to use your source code control system to do branching, you need an alternative. And so this technique of branching by abstraction is where we ended up going. So did we realize our dream? Were we able to fly, metaphorically, these drones to the customer? Well, things were really rough before, but as we started to apply these principles, we got much better. And towards the end here, it was, I think, 34 out of 36 weeks, we were able to meet our goal and get new batches of features into production. We weren't tracking our velocity initially all the way into deployment, so the statistics I could give you about our velocity wouldn't help. I can tell you that it did improve, but I can't give you metrics. So that was another lesson learned, was to track the velocity all the way through that pipeline. So in conclusion, lessons learned. First realization, architecture impacts batch size in ways that we didn't anticipate. Decoupled deployment, getting more granular, using, again, especially in the cloud, leveraging the ability to deploy microservices and leveraging automation to do that, such that all we needed to do is check in the code and watch it flow through. And again, this virtual sort of pipeline. So again, virtualizing the pipeline using branch by abstraction, feature switches, and all of this helps you do piecemeal deployment of those services in a way that helps you solve that problem of what happens to those changes that cut across the different components within the stack. So in the end, not surprising, I couldn't say anything different here at Saturn, right? But architecture matters, and in this case, we wish we had known sooner how much it mattered in terms of our goal of getting to continuous delivery. All right, that's all I have. Thank you.
Well, we have time for questions. Yeah.
I guess this is, you were describing a greenfield project, but how would you apply this to, like, you know, a legacy project or an existing project? So I got an application I've worked on for like 6 years, and we're thinking about really fundamentally transforming it. I only have like 6 resources to do this. So how do I do continuous delivery in a week? You know,
Right.
features, and I got to deal with bugs. I don't know if we're going to have automated acceptance testing. I'd love to hear how you do that. Because
Right.
acceptance testing to me is my stakeholders together. What's right and want that out.
Yeah.
So I'm just curious.
Yeah, and some of that goes to cultural issues and
Right.
things that are beyond the scope of this particular set of concepts. But in terms of, certainly these concepts could be applied incrementally in terms of, and I don't know if it's in the cloud or not, that's another, probably not, right? But at the same time, there's no reason you can't start to do automated acceptance tests. The tools are out there in Java and .NET. The BDD type tools can be applied to do automated acceptance tests, even if you're not really doing behavior-driven development and so forth. And that's, we've got a lot of mileage out of those tools. So I think the challenge would be, yeah, so where do you start, right, in terms of what's going to buy you the most payoff first? And, so I think creating that build pipeline and just starting down that pipeline and trying to build out. First, the continuous integration, you got to start there, and then, and then as you start to get that going, so that you're maybe automatically building, and you start to add in the automated acceptance tests and unit tests at piecemeal, and don't try to do it all at once, right? Find the things that matter most, that break the most often. Where are you seeing the most pain for not having automated testing, and address those areas first. Where is the most exposure in terms of not having testing, and start to build those pieces and automatically test them early. But we can talk more after this if you want to find me, because there's a lot more to talk about there.
Okay, more questions?
So when we build the model, I'm sorry, next question. What will change if embedded systems for not only deliver software, but
The device as well.
give you some proposals?
Well, part of this project actually wasn't an agent, what we call a Sentinel, that actually lived out on the remote work server. And, so in terms of doing monitoring of on-premise systems from the cloud, we had to build a piece of software that could be installed and deployed on those on-premise servers. And so we did a lot to be able to automatically update that. We treated it almost like it was a rover on Mars that can't update itself and so forth. So we have a way to push out those updates. So in terms of doing continuous delivery or deployment to an embedded device, obviously you'd have to work out the connectivity issues, and I don't know if these things are already on the internet or otherwise reachable. But we had to solve a similar problem here, where we were that software was calling back to us. Do I need to update? Do I need to update? And then we could push those changes out automatically to it, even behind the firewall. So if that answers your question at all.
More questions? So I have one. Diane talked about rollback. So could you give us some sense of how many times you deployed and you had to roll back, and how hard it was, and what the process was?
All right. And so again, these feature switches go a long way to helping you. So when you define rollback, you have to broaden it to, did you just turn off a feature switch that maybe you turned on and you were a little too quick to turn it on? Or again, some of these techniques, you can have 2 versions out there, one of them dark deployed, and instead of rolling it back and pulling that back out of the production system, you tell it not to use that version anymore. So if you go back to this slide, let's see if I can just a page up here. Yeah, so like here, so if you have 2 versions out there, the client can be telling it which version to be using. So over here on the far side, so once you've deployed 2 versions, if the client is the one subscribing, you have more options, you have more freedom to not do a full rollback. I don't remember exactly, but it wasn't that often. It wasn't that frequent that we were doing rollbacks. We tried to do the roll forward as they talk about by, for one, not reacting. So how severe is this issue really? What is our risk of making it worse by pulling those changes back out, especially if you've already impacted the database schema or other kind of more persistent changes were in place. So I felt we did pretty good on that front, and we didn't roll back. I can remember twice going back into production in the last 6 months.